Let's explore some possible causes for the low voltage readings at some receptacles and the shocking light switch experience. For the receptacles reading 90.1 volts when other receptacles on the same 20-amp 120 volt circuit read 119 volts, several factors could be at play. Firstly, loose connections at the receptacles themselves or at any junction boxes along the circuit's path are a prime suspect. A loose connection creates resistance, impeding the flow of current and causing a voltage drop. It's like a kink in a garden hose restricting water flow. Secondly, faulty wiring, such as damaged or undersized wire, can contribute to low voltage. Damaged insulation can lead to current leakage. An undersized wire simply cannot handle the current demand without significant voltage drop. Thirdly, high resistance in the circuit can stem from corrosion or oxidation at connections. Corrosion acts as an insulator, hindering current flow. To address these receptacle issues, a systematic approach is necessary. Firstly, turn off the circuit breaker to de-energize the circuit. Secondly, carefully inspect each receptacle and junction box, looking for loose wires, corroded connections, or signs of damage. Thirdly, tighten any loose connections securely, ensuring proper contact. Fourthly, if you find corroded wires or connections, clean them thoroughly with a wire brush or appropriate cleaning solution. Fifthly, if the wiring appears damaged or undersized, consider replacing it with the correct gauge wire. Now let's turn to the light switch issue where you experienced a shock and measured 70 volts. Several potential causes exist. Firstly, a problem with the wiring to the switch itself is a possibility. This could involve a loose connection, damaged insulation, or incorrect wiring. Secondly, a stray voltage causing a phantom reading is also possible. This can occur when a nearby appliance or faulty grounding introduces a small voltage onto the circuit, even when the switch is off. Thirdly, a malfunctioning circuit breaker or fuse could be contributing to the problem. A faulty breaker might not be fully disconnecting the circuit, allowing some voltage to leak through. Fourthly, poor grounding can also lead to voltage present on the switch even when it's off. A properly grounded circuit provides a safe path for straight current to flow, preventing shocks. To address the light switch issue, firstly, turn off the circuit breaker to de-energize the circuit. Secondly, carefully inspect the wiring to the switch, looking for loose connections, damaged insulation, or incorrect wiring. Thirdly, use a non-contact voltage tester to verify that the circuit is indeed de-energized before touching any wires. Fourthly, tighten any loose connections securely, ensuring proper contact. Fifthly, check the grounding connection at the switch box and ensure it is properly connected to the grounding system. Sixthly, if you suspect a phantom voltage, try disconnecting any nearby appliances or devices to see if the voltage disappears. Now, here are some additional possibilities that could contribute to both the low voltage receptacles and the shocking light switch scenario. Firstly, an overloaded circuit drawing more current than it can handle can cause voltage drop at the receptacles and increase the risk of shocks. Check the total current draw of all devices on the circuit to ensure it does not exceed the circuit's capacity. Secondly, incorrect wire sizing or gauge can lead to both low voltage and increased shock risk. Ensure that the wire gauge is appropriate for the circuit's current carrying capacity and length. Thirdly, damaged or loose neutrals can cause erratic voltage readings and increase the risk of shocks. Inspect the neutral connections at the receptacles, switch, and circuit breaker panel to ensure they are secure and in good condition. Fourthly, a ground fault in the circuit can create a path for current to flow through unintended paths, leading to shocks. Use a ground fault circuit interrupter, known as a ground fault circuit interrupter, to protect against ground faults. Fifthly, electrical surges or power fluctuations can damage wiring and components, leading to low voltage and increased shock risk. Consider installing a surge protector to protect your electrical system from surges. Regarding National Electrical Code, known as NEC references, several articles might be relevant to these issues. NEC Article 210.19 addresses conductor ampacity and overcurrent protection, which relates to correct wire sizing. NEC Article 250 covers grounding and bonding requirements, which are critical for safety. NEC Article 300.11 addresses securing and supporting wiring methods, which relates to proper installation practices. NEC Article 310.15 provides guidance on allowable ampacities of conductors, which is relevant to wire sizing and current carrying capacity. NEC Table 310.16 provides specific ampacity ratings for different types of conductors based on their size and insulation. If the wire is too small for the intended load, this table can be used to determine the correct size. It's crucial to use the correct size wire to prevent overheating and potential fire hazards. Regarding grounding, the NEC emphasizes the importance of a properly installed and maintained grounding system. The grounding system provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device such as a circuit breaker or fuse to trip and de-energize the circuit. This helps to prevent electrical shock and fire hazards. Grounding electrodes, such as ground rods or ground plates, are used to connect the electrical system to the earth, providing a stable reference point for voltage and helping to dissipate surge voltages. The NEC also requires bonding of metallic components such as metal conduit, metal enclosures, and metal water pipes to the grounding system. Bonding ensures that all metallic parts are at the same potential, minimizing the risk of electric shock. Ground fault circuit interrupters, also known as ground fault circuit interrupters, are another important safety device required by the NEC in certain locations such as bathrooms, kitchens, and outdoor areas. Ground fault circuit interrupters are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing electrical shock. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety and the safety of others. Working with electricity safely requires a thorough understanding of electrical principles, proper techniques, and adherence to safety precautions. Firstly, always de-energize the circuit before working on any electrical components. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, use a non-contact voltage tester to verify that the circuit is de-energized before touching any wires or components. Thirdly, wear appropriate personal protective equipment, also known as personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical shock and other hazards. Fourthly, never work on electrical systems in wet or damp conditions. Water is a conductor of electricity, and working in wet conditions significantly increases the risk of electric shock. Fifthly, use insulated tools when working on electrical systems. Insulated tools help to protect you from electrical shock by providing a barrier between you and the energized components. Sixthly, never overload electrical circuits. Overloading a circuit can cause the wires to overheat and potentially start a fire. Be aware of the current carrying capacity of the circuit and do not exceed it. Seventhly, inspect electrical cords and plugs regularly for damage. Damaged cords and plugs can pose a shock hazard. Replace any damaged cords or plugs immediately. Eighthly, use ground fault circuit interrupters, also known as ground fault circuit interrupters, in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Ground fault circuit interrupters can detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing electrical shock. Ninthly, be aware of the location of overhead power lines. Maintain a safe distance from overhead power lines to avoid the risk of electrocution. Tenthly, if you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety and the safety of others. When troubleshooting electrical problems, it is important to have a systematic approach. Firstly, start by gathering information about the problem. Ask questions such as when did the problem start, what are the symptoms, and what has been done to try to fix it. Secondly, inspect the area around the problem for any obvious signs of damage or loose connections. Thirdly, use a multimeter to test the voltage, current, and resistance of the circuit. Fourthly, compare the readings to the expected values to identify any discrepancies. Fifthly, use a process of elimination to isolate the problem. Disconnect or remove components one at a time to see if the problem goes away. Sixthly, once you have identified the cause of the problem, take steps to repair it. This may involve tightening loose connections, replacing damaged components, or rewiring the circuit. Seventhly, after you have made the repairs, test the circuit to make sure that the problem has been resolved. Use a multimeter to verify that the voltage, current, and resistance are within the expected values. Eighthly, document your work. Keep a record of the problem, the steps you took to troubleshoot it, and the repairs you made. This will help you to troubleshoot similar problems in the future. When working with electrical systems, it is important to follow all safety precautions. Firstly, always de-energize the circuit before working on any electrical components. Secondly, use a non-contact voltage tester to verify that the circuit is de-energized before touching any wires or components. Thirdly, wear appropriate personal protective equipment, also known as personal protective equipment, such as insulated gloves and safety glasses. Fourthly, never work on electrical systems in wet or damp conditions. Fifthly, use insulated tools when working on electrical systems. Sixthly, never overload electrical circuits. Seventhly, inspect electrical cords and plugs regularly for damage. Eighthly, use ground fault circuit interrupters, also known as ground fault circuit interrupters, in areas where there is a risk of electric shock. Ninthly, be aware of the location of overhead power lines. Tenthly, if you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician.